Hey everyone, welcome to another live coding. And this coding is going to be a little bit special because it will be a bit less coding and a little bit more about me talking about the updates which are incoming, why we're doing them, a little bit more in depth what they are, and then finally showing a demo on how it's looking right now. So let's jump into it. I prepared a little deck for it. Um, so, as I just mentioned, I'll start with just going through some background to the changes, why we're even doing them, and then what do we want to do, what do we want to change, then what the different solutions we have are, some positive and negatives you can expect with a solution, and then finally the demo. So starting by going into the different background or into the background of these changes. So a little bit before the winter, after the earlier large launch we had, we noticed that we had a bit of a drop off before users even trained the model. So a lot of people would come in. They would try to build a model, and the model would either crash when it pressed run, or they didn't load the data properly, or something with the model didn't quite go right, so they never got to the training part of it. And speaking of data, there's also a bit of confusion around the data. A lot of people don't know that we even handle more than just NumPy files. For example, you can already in the tool read in files like CSV, JSON, image files, image folders. But since pretty much all the tutorials and all my live streams are using NumPy, because it's a very, as a developer, it's a very easy way to test something and to debug something and build something around. The impression is that NumPy is the only file you can use very often. And then the last thing we wanted to address is we wanted everyone to be able to get value faster out of the tool. And what I mean with this is building models from scratch is awesome, but it takes a lot of time, and you very often want to have some kind of baseline very early and then go from that baseline and iterate on it. Or you want to use some cutting edge TensorFlow model, for example. So we wanted to let everyone get to this baseline a lot quicker somehow. So that's a little bit of the background to the changes. So what do we actually want to change then? First of all, we add in pre-trained models, and this is something I've already shown in a previous live coding. This is a bit of a no-brainer. Adding in pre-trained models lets anyone just pick out a mobile net and run it. And they can run on their data in no time with really good models and get good performance. To tackle the data issue, we were looking for a standardized way to handle data. Right now we are very all over the place. The first approach we had is let anyone load any data file or any data however they want. But there are some downside with that, so we were instead looking for a more structured or standardized way to deal with the data. And then finally, for that little bit extra value and adding a baseline to get to very quickly, we wanted to be able to recommend models. Based on whatever data you loaded into the tool, you should get a model which at least works. And the current templates we have right now don't really do that. And we have something called auto settings, which is a decent step on the way, but it won't give you a full model. So those are the main things we set out to change. Now, how did we go about doing it? Or what was the solution? So we started with looking at the recommendations, because we figured if we can solve the recommendations, that's a great step on the way. And we began by looking at neural architecture search algorithms or frameworks such as AutoKeras. And AutoKeras specifically, we looked at how AutoKeras works is they have essential Keras components, but each of these components can have both neural architecture search in them and hyperoptimization, hyperparameter optimization. So if you dragged out a convolutional AutoKeras component and ran that, it would try to find how many layers of convolution there should be in that component, and not only trying to find how many how large or the different settings in that, which would be hyperparameter optimization instead. And AutoKeras could have worked pretty well. We could, in that case, integrate it, work alongside with Keras, so you could have AutoKeras and Keras components inside PerceptiLabs. The problem with neural architecture search or AutoML in general is that it takes a while to get your model, and it requires quite a lot of resources. So we figured it might not be the most efficient way of getting your baseline. So what we started looking at instead is a framework called Lundberg, which is built by Piero Malini, which my co-founder has been in contact with before, and we like that framework a lot. And how it works, to give a brief overview, I borrowed this from one of his white papers. It takes an arbitrary amount of inputs, an arbitrary amount of outputs, you can specify which different data type it should be. And for every input, it just encodes that input into some representation. So to make it a little bit more concrete, if you have image input, for example, it would take that. You could have, as an encoder, a few layers of convolution, or you could have a mobile net base. And the goal here is just to get some representation of whatever input you have. Then you take all of these results, you combine them, and then you tag on a little decoder at the end. And this decoder then has the purpose of transforming this representation into something actually usable, into some kind of output that you want to have. And in this way, you can combine multiple inputs and have multiple outputs in the same problem. So it's a very neat way and a very modular way to have multi-inputs and multi-outputs. And it's quite a brilliant solution. The problem we had here, though, is that our first thought was to use Lundberg as build on top of it, essentially, similar to AutoKeras. But that didn't quite work. Lundberg is... if we were to integrate Lundberg into the tool, we would have to rebuild the entire kernel with Lundberg as the base, similar to how we have TensorFlow as the base right now. And we would also have to rework the workspace, because Lundberg is a bit more rigid, a bit more strict with how it works, so our normal components wouldn't work in it. And we really like the flexibility of our normal components right now, so that's not something we wanted to go away from. So instead of building on top of Lundberg or integrate Lundberg, which was the first thought, we borrowed a bit of this idea and attempted to do this in PerceptiLabs instead, and use this as a base for recommending different models. Another benefit which comes with this is what you feed into Ludwig or feed into this system in general is a structured data set or a tabular data set. And this could be something like a CSV or an Excel or a JSON, anything with that kind of structure to it, which solves our other problem with how are we supposed to get or what structured data should we use. So the result of this is that we started looking at using tabular data as the standard data inside of PerceptiLabs, and then based on that be able to recommend models in this fashion. And that entire package of loading in a CSV file or any structured data file together with defining that data and then finally recommending a model, that's all what we call the data wizard, which I'll show very soon. Now, there comes some positives and negatives with this. To go over the negatives first, inside of this architecture, it's very difficult to fit things such as GAN, reinforcement learning. So we might have to say goodbye to those for a little bit, at least in this first version. The positive thing with it though is we get the structured data set, as I said, we get the recommended models. We can move very quickly on it, because if we wanted to introduce another input data size or another way to recommend models, we can very, very easily do that and very quickly expand on other domains inside machine learning. As an example, one of the first models we're going to, or data types we're going to release with is text models. And if you combine those with classification, for example, you would have text classification, or you can combine that with images and you would have image captioning, which is something we couldn't really do before. So that's the background to the different changes which we're looking at doing right now. And to show how it actually looks like inside the tool, let me swap over here. So this is a demo version of PerceptiLabs which I'm running, or not a demo version, it's a developer version, our master branch. So in here, as you can see, this looks exactly like it did before, but as soon as you go to create a new model, you'll see that the templates are no longer there, and that's because we're now going to use recommended models instead. So the first thing it asks you to do is to load your data. So I'll just go in here and take a standard MNIST. And as soon as you do that, it will show you the dataset you loaded, and it will show you a little preview of it, and you also get to define it. So what I mean by defining it is that you get to say which columns are input, which columns are output, and then you also get to say which type of columns these are. So right now we just have imaging numerical in this build, but I could then set column 1 to be an image column and column 2 to be a numerical one. And based off of this, we'll be able to do a recommendation. Another change which comes with this is that rather than being able to add and pull data as you want inside of the workspace, the model itself will be very data-centric. And what that means is, as soon as you create a model around the dataset, it stays with that dataset. And that's because if you wanted to change it, say you wanted to remove a column, and we want to do some recommendation for that, that would override your existing model, which may remove some work you already did. And we're gonna look at making support functions so you can add columns, so you can replace your rows inside it or your data inside it. But as a start, if you want to run on a different dataset, you would just create a new model. So let's go ahead and create this. And when doing that, it's going to take a little bit, and then it's going to be misplaced a little bit because it's very early. But as soon as you finish loading, you'll see that we now have a model ready to go. And it has there is no longer a data component, there's an input component instead, it's called. It has the data already loaded inside of it. This input component will also be responsible for pre-processing the data as needed. So if this was text instead of image, this input component would automatically pre-process it or embed it, so you get numbers out instead of the text strings. And similarly, we don't have a training component any longer. It's now an output component. And inside this output component, you have the labels. And they're being pre-processed the same way as the input is. So if we have text here, it's going to embed. If we have categorical, it's going to do the one hot. So a lot of that is now automized and taken care of. Of course, you'll be able to change it with settings, but much of that is probably something you won't touch, since it's changing like embedding text, for example, is something you're going to have to do anyway. And another change while we're in here as well, since the training component is gone, so you're instead using this output component. That's kind of how we're now able to have multiple outputs. So you can have a multi-output problem very easily. And the training itself is, instead of tied to a component, it is workspace-wide. And it's also the custom code of the training component, which essentially is the while loop and the session, is now being hidden away, so we can optimize it easier in the background. But you will still have access to the loss function and everything like that. Let's see if there was anything else before I start training it. I think that's about everything. So after we start training it, it looks kind of like how it does today. We're still working on getting the different statistics into this new trainer. One nice thing is that it seems to be running a lot smoother and connect easier to the GPU than the other training script did. So this might look like it's training a little bit slow, but we're actually running on 100 epochs, so arguably it's running a lot faster. Got a question, what is I/O? Is that something new? So I/O is the input and output components, and they're replacing the data and the training components. And the input component is essentially the data component, but it also contains a little bit of pre-processing. And the output component is a combination of the loss and pre-processed labels. So the training component itself becomes the workspace in a very overview way. So yeah, that's let this one finish. We still have to get the test into this version, which is another update that's coming with this release. We're going to have a few more tests, or at least a few more interesting tests which you can run. Other question, is this version available now? Not quite yet. We're expecting it by the end of the month or middle of next month to be available for everyone. If you're interested in testing a very early version though, feel free to reach out to me and we'll see if we can hook you up a little bit earlier. I wouldn't recommend testing this one too much though, because it is still a bit bare bones. The architecture is in place, but we need to get all the rest of the features in there. So yeah, that's a bit of a summary of this change. It's a bit larger change, but our hope with the change is that it will it lets you build much more flexible models in terms of inputs and outputs, and it will also let you get the model up and running much quicker than it does right now. Together with this change, we'll also swap over to TensorFlow 2, so it will be a bit easier to customize the code if you want to do that, and will in general just run smoother. And then to other components, to other changes which are coming a little bit later down the line, is that we'll be looking to making projects as well, and these projects can then contain multiple models, and more importantly, a data processing view, where you can see the data you loaded into the project, you can pre-process and manage it and wrangle it. And then we're also looking at making this available on the cloud. So you don't have to do the local install every time you want to try PerceptiLabs. You just jump on the cloud, it will run perfectly, and we'll have good machines for it. Got a question from another question. First time viewer, can you show the network topology from this view? So this would be the network topology. So you're able to see the different components, and the different components would contain a con, for example, contains more just a convolution. It's also bundled together with the activation function, the dropout, pooling and batch normalization. But at the very top, you can see the dimensionality of it, the output of it. So that's an easy way to track the architecture of the model you're building. Can make another quick example of how it would look like with just that's the wrong one. Data. Here we go. With just numerical instead. So it's very easy to change the dataset you're using, and you just press create, and you'll get a model ready to start running. And the cool thing about that is you're up and running quickly, and then after you run it and try it out and got your baseline, you can very easily go back and start changing it again. I'm thinking of the interconnection between the layers and neurons of the model. So you can see the connection between the you can't see it neuron by neuron in this view when worn, but you are able to see which layers connect to which layer. So if you wanted to connect this one to a separate layer, you will be able to do that as well. So you can see skip connection, everything like that. A request to make a tutorial how to create something with our current neural network. That would be cool. That's something we can look at doing. Okay, but that was everything I had to show off for today. Hopefully you guys liked it. I'm really excited for these changes. It will make the development go a lot faster on it, and I think it's in general will create a lot more robust and flexible models. Got another comment. I'm interested in seeing which neurons are most active, weighted by the weights and pruning. those are less active in modifying the layer count a la TensorFlow Playground. That's a great comment. And that won't be directly available in this view, but we will have tests showing saliency map and things like that, which can allow you to see exactly what you're saying, which neurons are activated most, depending on the different inputs or depending on the desired outputs. And from that you can iterate on the model and try pruning it. Okay, but thank you very much everyone for joining me in this live, not really coding, but a little bit of coding. And hopefully you're excited for the changes as well. Let me know if you have any thoughts on them. We love feedback. You can always reach me on the forum.perceptlabs.com, or on our Slack channel. But until next time, take care.